Hi guys, in this video I will explain how to implement a linked list. If you're not familiar with the linked list yet, please check out my other video on what a linked list is. I put a link in the description below. I will not use any templates in my implementation. I really want to keep the implementation very simple, so I created a linked list of integers. Before taking a closer look at the linked list class, I want to take a look at the node class. The node has two member variables, value and next. Value represents the value that is stored in the node. In my case, it is integer because I have a list of integers, but this could really be anything, and you could use a template to store any type of data in a node. The next member variable is a pointer to the following node. I have a default constructor, a constructor that expects a given value that will be stored in the node. I have a setNext function, which updates the following node. I have a getNext function, which returns a pointer to the following node. And I have a hasNext function, which checks if the following node exists. And I have a getValue function, which returns the value in the current node. Let's take a look at the CPP file. The default constructor calls the constructor that expects a value and passes 0 to it. And this constructor initializes value with a given value, and it initializes next to null. The setNext function updates the following node by taking in a pointer to a node and copying the address of the next node to the same named member variable. So now next points to the next node. GetNext returns a pointer to the next node. HasNext simply checks if next does not equal null, so it checks if a following node exists, and getValue returns the value of the node. Now let's take a look at the linked list class. The linked list class has a single member variable, which is the head pointer. This points to the head node, and it's initialized to the null pointer, so initially the linked list is empty. It also has a delete last function, which expects a node, and this deletes all the nodes in the linked list. This is a recursive function that is called by the Destructor. Then I have a constructor, which is very simple. The implementation doesn't have any statements. And I have a few functions, such as add, which adds a value to the linked list, get, which returns a value by a given index, contains, which checks if a target value is contained in the linked list, remove, which removes a value from the linked list, size, which returns the number of values or the number of nodes, if you will, in the linked list, and finally a print function, which prints out the values stored in the linked list. Let's take a look at the CPP file where I implement these functions. So initially I have the Destructor. The Destructor checks if head is null. If that's the case, there's nothing to delete, so it returns. If there is a node, it checks if the head node 5 has a next node, which would be 7, and this would be true in this case. So here it will call delete last and pass 5 to it. 5 is the head node. So let's take a look at delete last. As I just mentioned, 5 is passed to it, so n is 5. 5 is not null, and it also has a next node, so this condition here is false. So it skips this. It does n get next, so n being 5, get next would be 7, and it checks if 7 has a next node. 7 does have a next node, which is 3, so it calls delete last with n get next. N is 5, and get next would be 7. So it calls delete last with 7. So n is now 7. It's not null, it has a next node. This is skipped. So n get next is 3. So 3 has next is false. So this condition is false because 3 does not have a next node. 3 points to null. Then n get next. So n is 7, and get next would be 3. So next here will point to the node with 3. Then n set next will update this pointer here, the next pointer of the node 7. And I pass null to it, so now the next pointer of 7 will point to null. So 7 will point to null. I removed 3 from the linked list, but I yet have to delete 3 and free up that memory. So here, this one deletes the node 3 and frees up the memory. Then I return from the function call of 7. This was called from here with n 5. So now 5 get next will return 7. So next points to 7. N set next, this is 5. Set next, and I pass null to it. So set next will point now to null. And then I delete next. Next was 7. So 7 is deleted and the memory is freed. And then I return from the function call with 5. This was called from the destructor right here. So now head is assigned to temp. So head is 5. So temp now points to 5. And I update this linked list here as well. So this is what it looks like. Now I update the head pointer to point to null. So 5 is effectively removed from the linked list. And now I call delete temp. This deletes 5 as well. So all the nodes were deleted from the linked list. And this was done in ON. And that's why I used a recursive call, because I always have to keep track of the previous node when deleting a node from the linked list. With that, let's take a look at the add function. Add adds a new value to the linked list. The first edge case is checked if head is null. If head is null, and let's say we pass in 4 to it, a new node is created with 4 and assigned to the head node. So here this will look like this. A new node, for a new node the next pointer always points to null, and then 4 is assigned to the head node. And then that function call is done and it returns. Now let's say this function is called a second time with 9. Head is not null, so this code block is skipped. So head is assigned to the temp pointer. So temp now points to head. And then I check if temp has a next node. Temp does not have a next node, this is null. So the while loop is skipped altogether. And now a new node with a value is created. So I mentioned, I assume 9 is being passed in. So a new node with 9 is created. And then temp set next. So temp set next this pointer here to point to the new node that holds 9, and then 9 was effectively added to it. Now let's do it one more time. Let's say 5 is being passed in. Head node is not null, this is skipped. Head is assigned to temp, so temp now points to 4. Then it checks, is there a next node? Yes, there is. 9 is the next node of 4. So temp is updated to temp get next. Temp get next gets 9 and assigns 9 to temp. So temp now points to 9. And then it checks again, does temp have a next node? It does not, it's null. So the loop ends, it creates a new node. Value being 5, it creates a new node of 5. And then 5 is set to the next node of temp. Temp next, so setting next updates this pointer to point to 5. And this is how the add function works. Now let's take a look at the get function. So this is get by index. If there's no head node, it returns -1. There's nothing in the linked list to store. Otherwise, it creates a temporary pointer to point to the head. So temp points to 5. And then it uses a loop from 0 all the way to index and updates temp to the next node. So initially I is 0. Let's say the index is 2. So I is 0. 0 is less than 2. So temp is updated to temp get next. Temp get next is 7. So temp now points to 7. And then it checks if temp is null. It's not null. So it skips this condition. Then it increments I by 1. So I is now 1. 1 is less than 2. So does temp equal temp get next. So temp get next. Temp now points to 3. 3 is also not null, so it skips this block. Increments I by 1. So this is now true. The condition here is false, so I will not enter the code block anymore. And then it returns temp get value. So temp get value would return 2. So for index of 2, index 0 would be 5, index 1 would be 7, index 2 would be 3, and this successfully returned 3. Let's take a look at the contains function. So contains checks if a given target value is contained in the linked list. Let's say we want to check if 7 is contained in the linked list. So initially, I create a temporary pointer that points to the head node. So here again, I have temp pointing to 5. Then I check if temp is not null. This is the case. Then I compare the value stored in temp to the target value. So I mentioned the target value, we assume it's 7. Does 5 equals 7? This is false. So it skips this block and updates temp to the next node. So temp will point to 7. Temp is not null, so it checks if the value stored in the node equals the target value 7. This is true, and then it returns true. Now, if target would be 9, for example, this condition would still be false. It would skip this, update temp to the next one. Temp is not null, then it would check if the value stored in temp, which is 3, equals the target value 9, which is false, and update temp to the next one. So temp would effectively point to null as well. Then it checks if temp is not null, this is false, so it stops the loop and then returns false, that nothing was found. So these were the two cases where a value is found in the linked list, it returns true. If it's not found and it walks all the way to the end of the linked list, it returns false. Now let's take a look at the remove function. So let's say we have an edge case and we want to remove 5 from the linked list, which is the head node. So if value is 5, we first check if the head points to null. In this case, it does not. If it would be, I would return there's nothing to delete. Next, I check if the value stored in the head node, which is 5, equals the value being passed in. And I mentioned this would be 5 in this example. This is true. So it creates a pointer temp that points to 5 to the head. Then it updates head to head get next. So head get next is 7 and assign 7 to head. So basically head will now point to 7. And to keep it nicely, temp essentially still points to 5. But 5 was removed from the linked list, but the node still exists. So in the next line here, I delete the node 5 and free up the memory. And then I return true that 5 was successfully deleted from the linked list. Now let's do another example. I add 8 here and I add 4 as well. So let's say 8 is being passed in. So initially I check head is not null. So I skip this. The value in the head node does not match 8 as well. So I skip this too and then I'm down here. So let me copy this. So value is 8. This is the linked list. And this is the code I have to work with. So I create a pointer to point to the head node. So temp points to 7. Temp has a next node, which is 3. So I enter this block of the while loop. And then I get temp get next. So temp get next. The next node of temp is 3. And I assign 3 to the next pointer. So here, next will point to 3. Temp still points to 7. Then I check the value stored in next. So next get value, this is 3. And check if it equals the value being passed in, which is 8. This does not equal, so I update next to temp. So now temp and next is the same. This is kind of what it looks like. They both point to 3 at this point. I check if temp has a next node. Temp next is 8. So it does have a next node, and then I update next to point to 8. So this is kind of what it looks like. So temp points to 3, next points to 8. And now I check the value stored in next, which is 8. Does that equal the value being passed in, which is also 8? This is now true. So I found the value that I want to delete from the linked list, 8. Now I do temp set next. So temp is 3. Set next would update this pointer here to point to next get next. Next is 8. Get next is 4. So this is 4, or to be specific, this is the node that stores 4. And this node is now assigned to temp set next. So this will point to 4. Note that I still have next, which still points to the node 8. So 8 was effectively removed from the linked list, but it still exists in memory. So on the next line here, I delete 8 and free up the memory. So this is then deleted, and I return true. And then I effectively deleted 8 from the linked list. Now let's check its size. Size simply counts the number of nodes. So if head is null, the size is 0 and 0 is returned. Otherwise, the count is initialized to 1 because I know at least I have the head node if the head node exists, and I check that by this point. So count is 1, then I create a temporary pointer to point to head, and as long as there's a next node, I update temp to the next node and increment count. So this basically walks through the linked list node by node and always increments the counter by 1 for every node that is found. And at the end, it returns the count. Now at the bottom, I have the print function. I will not go into further details. Let's take a look at the main function. In the main function, I create an object of the linked list. Then I call the add function 4 times. I pass in 5, 7, 3, and 9. Then I call print to print out the linked list. And then I call remove 5 and remove 3 and print out the linked list again. Now when I run this, so initially I have the head pointer that points to 5, then 7, 3, and 9. Then I call remove 5 and remove 3. This removed 5 from it and 3 from it. And now the linked list is the following line. Now head points to 7, 7 points to 9, and 9 points to null. I hope you enjoyed this video. Thank you for watching.